Okay, Tarryn, so I'm looking at the pictures, and this one says Motion Quiz A, and it says that you lost 14 points out of 40. So when I look at it, I'm going to look at the first picture, and then I'm going to go look at that second one and see where you are. So hang on, I will come back and talk to you about why you lost those points. Okay, so I looked at the first two pictures, and it looks like you did fine on the first one, but you started losing points on the second part. So we're going to talk about those. Now, when you have a position versus time graph, first of all, when you have any kind of graph, make sure you look at it and understand what it's showing you the motion of or the graphing of. I'm having some trouble here. So what I mean by that is read that X and Y axis very carefully. Don't just assume, because it's so easy to do. Time should always be on the X axis about 99.9% of the time, and this is position, which you already know. And so it looks like it sits still for a while, and then it does this, and then it sits still for a while, and then it does that. Okay? So that's the general shape of the graph. Here it does not change position, so I think it was at 0.2. I don't really know. I mean, I'm pretty sure that's what the number was, and it lasted for 2 seconds. So if that's what's going on, this position here never increased over the 2 seconds. It didn't change at all. So the speed there had to be 0 meters per second. How do I know that? Take the slope of a line. So the slope of a line on a position versus time graph, or D versus T graph, position versus time, will always give you the average speed. Always, 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 always. So if that's what's going on there, then you need to recognize that it didn't change position, so it didn't have a slope. The slope is 0, so if the slope is 0, it has no speed. It's that simple. Don't make it hard on yourself, okay? All right. So then it says, well, what was the average speed when it went from... All right, I'm trying to get everything tucked away and arranged up here. So that was from 0 to 1 seconds, my bad. Okay, now it goes 1 to 3. So that should have been 0 to 1 second. So that's stupid right there. So that should have been 1 second. Okay, now it wants to go from 1 to 3 seconds. All right, if you look at your graph, it looks like it's at a position called 1 meter here. So for part B, the average speed is going to be the change in position. I'm going to call it distance for now, over the change in time. All right, so they want the velocity, so I have to pay attention to whether this value is positive or negative. Well, I'm going to take the final position, which is 1 meter, minus the initial position, looks like it was 0.2 meters. And it looks like it took from 3 seconds to 1 second. Look at every number I write, I have a unit on. So that's 0.8 meters divided by 2 seconds. And 0.8 divided by 2, it should be 0.4 meters per second. And it's positive, which means it's moving in the positive direction. Usually when I taught, I call the positive direction right or north. Okay? So just, it depends on how they want to define positive. Okay? There's part B. Let's look at C. C says the average velocity from 3 to 5. Well, if you look at that graph that I just erased, but you still have it on your page, it's a flat line from 3 to 5, and that's supposed to be a flat line. Okay? So that's from 3 seconds to 5 seconds. And that is 1 meter. Position never changes, so the average speed is 0. And since delta D doesn't change, it's 0. And then we want to go from 5 down to 7. It looks like this. All right, so average speed is change in distance over change in time. So I'll take the final position, which looks like it is 0.5 meters, minus the initial position, which is 1.0 meters, and that's the position that it had at 5 seconds. That's position at 7 seconds, and it lasted for 2 seconds, so it's going to be an average speed of negative. Well, when I subtract that from that, I get 0.5. 0.5 divided by 2 is 0.25, so it's negative 0.25 meters per second. And if you think about it, it makes complete sense. This is a negative slope. A negative slope should indicate a negative average velocity. This had no slope, so that's why I got 0. So if you'll just slow down and think about it and stop flipping out, because that's what a lot of people do, things will get better for you, I promise. So take your time. All right, so now let's look at the next one. Well, the next one is a velocity versus time graph, so it's going to be completely different than a position versus time graph. So make sure that you read your x and y axis. So this is velocity, which is just speed with a direction. It's in meters per second. And this is the time, and it's in seconds. Okay? So it looks like it has from A to B, and then it has from B to C, and then it has from C to D, D to E, E to F, F to G, and G to H. So there was A, B, C, D, E, F, whoops, G and H. Okay, so look at this. If I didn't tell you that this was a velocity time graph and you thought, oh, it's position, then you would say, well, it moves away, it sits still, moves away, sits still, goes back, sits still, moves away. But it is a velocity versus time graph, so different things are happening. Here it's speeding up, constant speed, the cruise control is set, speeds up, cruise control is set, slows down, cruise control is set, speeds up. Okay, so make sure you pay attention to that right there. That is so critical. All right, so then it says, how far does the object travel? Okay, but before we even answer those questions, let's talk about this velocity versus time graph. The slope on a V versus T graph is always going to be the acceleration. Always, 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 always. Okay? Now, the area under the curve, and I'll talk about that and what curve means in just a second. Area under curve, oops, is the displacement, or the distance that it traveled. And hopefully they went over the fact that displacement is simply the change in position from beginning to end. So if you are in track and you run around the circle like that, your displacement is 0. Even if you ran 100 meters around here, your displacement is 0. Because how did your position change from beginning to end? It did not. Okay? So it doesn't matter what went on in between, the displacement is 0. This distance could be 100 meters though. Okay? So this says area under the curve. Well, when you think of curve, you're thinking of something like that. In science, it could be something like that. It could be a flat line. Just any function on the graph is the area, is the curve they're talking about. So if you talk from A to B, that's supposed to look like a triangle. So that's going to be 1/2 base times height from A to B. That will be the displacement or the distance. From A to B is simply the area under the curve. So if you look at your graph and go back to your page with the actual numbers on it, it looks like it lasted 2 seconds here, and it rose 20 meters per second there. So if I take that area, which is just a triangle, it's going to be, all right, 1/2, base is 2, height is 20. Now if you look at those units, if you multiply these seconds by meters per second, you get meters, which is what I told you it should be because it's displacement. 40, half of 40 is 20. So this object traveled 20 meters in the first 2 seconds of motion. Okay? All right, now they want us to find the acceleration from A to B. Well, it's going to be change in velocity over change in time. Acceleration is change in delta V over delta T. So it went from 0 to 20 according to that picture. So the final is 20. The initial is 0. And the time was 2 seconds. And this is nothing more than what you did in your math class when you learned how to take the slope of the line. Okay? That's all this is. You're taking the slope of that line. Do not flip out. It's not a big deal. If you know it's a velocity versus time graph, then the slope will always give you the acceleration. You need to memorize these two facts. It's very simple. So 20 minus 0 is 20, divided by 2 is 10. So that's a positive 10. My units will be meters per second squared, and I'm going to show you why that's the units, because some students never get this, and you've got to know. So the top is like a fraction. The top is in meters per second. The bottom is in seconds. So it's meters per second divided by seconds. Well, let's do that math. Meters per second divided by seconds is the same thing as meters per second times, remember in fractions you change that to a multiplication and flip this over. So it's meters times 1, which is meters. Meters times 1, which is meters. And then seconds times seconds is seconds squared. So that's where I got that unit from. And when you accelerate, you're really doing nothing more than gaining speed per unit of time. So it's the change in your speed over the time that it takes to change the speed. Okay? All right, let me check how long I've been recording. Okay, I'm going to record another 4 minutes and we'll be good to go. So that was 5 right there. I think this was 6 right here. Now let's look at from D to E. Okay, so does the object accelerate from D to E? No, you did it correctly. You said 40 minus 40 over 8 minus 5. So 0 divided by 3 is still 0. There is no acceleration. Just be sure you put your units on there. Okay? How far does the object travel from D to E? Area under the curve, same thing again. So from D to E, it was really nothing more than a rectangle. Oh, that's a stupid looking rectangle, but you kind of get the idea. So from D to E, base times height, just like you did. So 8 and 5 gives me a base of 3 seconds, and the height goes all the way up to 40, it looks like to me. So that's going to be 120. And if I should have shown you the math, my bad. So 40 meters per second times 3 seconds. Seconds will cancel. 120 meters. Okay? And I'm wondering, is that the end of that one? Because that was really, you did not so bad. You just need to understand the relationships on the graph. And that will come with practice. And that's what you need to do is practice. So anything they give you to do, make sure you do it. All right.